All right, now we're going to deal with the idea of encapsulation. So, encapsulation. Encapsulation means that this class right here, I'm going to rename it, rename and save, that this class, when it's dealing with my point, that it doesn't have direct access to the instance variables. Here I can access, x and y directly. In fact, I can even say mp1.x equals -5 if I want. I can run that, and it works fine. And there's -5, 0. Okay, that works. But what if, for whatever reason, I wanted to make sure that the x and the y were always positive? So they were 0 or greater. There was no negative, there was no negative numbers for x and y. Well, okay, how do I do that? I mean, how do I stop people from directly accessing them? Because, people can say mp1.x equals -5. And when I say I don't want them to access it, it's not like I'm being mean. It's just simply if I don't let them don't let them directly access it like this, then they have to access it in a different way. So all I have to do is say private. So private double x, private double y. Now people can no longer accidentally change it. So if I go like here, x has private access in my point. So I can no longer just directly mess it up. I could try, but nope, I can't directly mess it up. So at this point, what I've done is I've made it so that you can only enter the initial data, but you can't ever change it, which is really not very useful. So I'm going to add something called a mutator. Public void, and then I'm going to say set x. I'm going to set a value. They're going to pass in an x and x. And if x is greater or equal to 0, then I will let them change it. I'll say, okay, this dot x equals x. Otherwise, I'm not changing it. I'll do the same thing with y. Public void set y and y. And so if y is greater or equal to 0, then go ahead and say this dot y equals y. Now if we look at this, which x is this referring to? The instance global variable or the local one? Well, this is the local one. Local always has precedence. So x, all right, I'm referring to that one. And this dot x, well, obviously that's the instance variable gets x. So if x is positive, then it gets set. Otherwise, it doesn't get set. Let's go test this. So I'm going to say mp1.setx -5. And then we'll say mp1.setY 5. If this works, well, or should I say, if it doesn't work, and it lets me change it, then when I do mp1.printme, it will print out -5 and 5. But if it does what it's supposed to, this will fail to change x, and so it'll remain the same value it was, which was 0, so it should be 0, 5 for the first one. All right, let's see, did it work? Aha! Yes, it did. That's non-5, and that is a +5. Pretty cool. All right. How do I actually get access to them, though? Well, this is a mutator right here. Mutator, also known as a setter. Well, a mutator or a setter sets or mutates or changes the value, but I want an accessor. Accessor, also known as a getter. And this is public, and this is going to return the value, which is a double, and then we'll get x. And all it does is return x. And that's all it does. It just says, you want the value of x? Here you go. I'm going to do the same thing with y, public double get y. and then return y. There we go. Okay, compile that, make sure that's good. And then here, I'm going to, in fact, what I'm going to do is I'm going to say that mp1.setX is whatever mp2.getX is. Ooh, we're getting really tricky. So mp2, the x is 3.4, so I'm getting that right here, and I'm setting it to mp1. So they should both have an x value of 3.4. And shoot, what did I do wrong? That's double, that's double. Oh, this shouldn't be int, this should be a double. Well, you probably knew that. Alright, let's make sure all the types are the same. Go back here, compile it again. Okay, so now we run it. Ta-da! So I try and set -5, that doesn't work, it stays as a 0, and then I get the value of the x, this is a getter or an accessor, and I set it to the value of x for mp1, making them both the same right there. All right, so that are accessors, mutators, and the whole idea is called encapsulation. Why do we care about encapsulation? Well, the point is, with objects, the actual data you shouldn't be able to directly manipulate because of all sorts of rules. The idea is there's only one place where I can change something. And so if there's a bug, well, if for whatever reason, if I've got this big project I'm in charge of, this class called my point, and somehow, the x is 0, well, if there's a whole bunch of places where x can be changed, that could take a long time to figure out how x became negative. And of course, if like a rocket were using my class and it suddenly had negative values, it could explode. And this has happened in the past. Many rockets have exploded because of software. So it's very important to be able to get it right. So if the only place where I can change x is in this one method, then this is the only place I have to check in order to fix my bug. And that's why we use encapsulation. Encapsulation helps with security and helps with errors and bugs and all sorts of things like that.